Today we are going to discuss about velocity analysis by using relative velocity method. We will discuss the method with the help of a problem. So the problem is, in a four-link mechanism, the crank AB rotates at 36 radians per second in clockwise direction. The length of the links are AB is equal to 200 mm, BC is equal to 400 mm, CD is equal to 450 mm, and AD is equal to 600 mm. The link AD is fixed, and at the instant when AB is at a right angle to AD, determine the velocity of 1. The midpoint of link BC, 2. A point on the link CD which is 100 mm from the points connecting the link CD and AD. First of all, we have to draw the configuration diagram, space diagram with correct dimensions or by using a scale factor. So after that we have to draw the velocity diagram. So from that velocity diagram we will be finding out the velocities of the point midpoint of the link BC and the point which will be 100 mm from the point D. Okay, so let us solve the problem. So these are the given values. AB is equal to 200 mm which is equal to 0.2 meter, BC is equal to 400 mm which is equal to 0.4 meter, CD is equal to 450 mm which is equal to 0.45 meter, AD is equal to 600 mm which is equal to 0.6 meter, and omega is equal to omega of the crank, that is the link AB, which is given as 36 radians per second, which is in clockwise direction. We can see that the link AD is fixed, A and D are fixed, and link AB, which is the crank, and this is rotating at 36 radians per second, and this link is perpendicular to the link AD, and this is the point E, and you can see that the midpoint of BC is E, which is 200 mm apart from B as well as C. And again, for the last question, for the link CD, we have to find a point on link CD which is 100 mm from the points connecting the link CD. CD is this and link AD is this. So the connecting point is point D, and from that point D we have to find the point F, which is 100 mm apart from the point D. Okay. So next we have to fill the table. The relative velocity as meter per second, and the scaled velocity in mm. This is actually the velocity diagram, scale of the velocity diagram, what all are the measurements that we are using for drawing the velocity diagram. Okay, first of all, the link name is AB, next is BC, next is CD, then AD. So next we have to find the velocity of the point E and the velocity of the point F. The length of the link AB is 0.2 meter. 0.2. It is 0.4. Next is 0.45. This is 0.6. Next we have to find the relative velocity. So relative velocity, first we have to find velocity of VBA, velocity of B with respect to A. So what is velocity of B with respect to A? So actually we know that V is equal to R omega. So here the R is equal to 0.2 and omega is equal to 36 radians per second square. So upon calculating, we will be getting as 7.2 meter per second. So upon calculating, we'll be getting the value of 7.2 meter per second. So the velocity of the link AB, that is the velocity of the point B with respect to A, VBA, the velocity VBA is equal to 7.2 meter per second. The unit is meter per second. Okay, so with this value we are about to plot the velocity diagram. So for plotting the velocity diagram, first of all we have to fix the point which are grounded. So from analyzing this figure, we can see that the point A and point D, okay, both of these points are fixed. So first of all we have to fix the point. We have to mark the point which is fixed and mark it as A, D. A and D are of fixed points. Fixed points means that it is actually the zero velocity points. It is actually the zero velocity points. Okay, so the velocity of that particular points will be 0. Any value with respect to these points are treated as absolute velocities. Any value of a particular link, any point on this 4-bar link is treated as the absolute velocities. First of all, we have to draw the velocity of the link AB. We know that the velocity of this link AB will be perpendicular to the link. Okay, now we can see that the velocity of the link AB is in this direction, which is perpendicular to the link AB, and the direction is in this sense. Okay, it is because it is in counterclockwise direction. It is in counterclockwise direction, so that the link will move like this. In this direction. Okay, at this particular instant the velocity will be perpendicular to this link at this point B. Okay, so we have to draw the velocity vector VBA. Okay, so now we are going to draw the velocity vector VBA, and which will be perpendicular to the link AB with a magnitude of 72 mm. So I am drawing this as 72 mm. Okay, so I am drawing this as 72 mm. So I am marking this dimensions of the velocity diagram over here. It will be much easy while your calculations are going on. This if you are following this particular format of table, it will be much easier. Okay, so I have drawn this AD, A comma D as the fixed point. Then I have drawn this velocity vector which is perpendicular to the link AB, and that value will be VBA, velocity of B with respect to A, velocity of B, and this is the actually the point B, velocity of B with respect to A. Next we have to consider the link BC. Okay, so velocity vector VCB, which means that's velocity of C with respect to B. Okay, velocity of C with respect to B. So next what we have to do is, the value is actually unknown. We don't know the value. Okay, the magnitude value which is unknown, but we know that the direction of this particular velocity vector will be perpendicular to the link BC. Okay, it will be perpendicular to the link BC. So I am just drawing this velocity vector, the direction of this velocity vector which is in perpendicular in both direction, either in this sense or in this sense. Okay, so both of these senses are possible. Okay, so from this point I am actually drawing this velocity vector which is perpendicular to the BC, perpendicular to the link BC. Sorry for the irregularities. I am just explaining the procedure how to carry out the velocity analysis. So next you have to consider the link CD. Next we are going to plot the velocity of link CD. Okay, so velocity of C with respect to D. Velocity of C with respect to D. Velocity of CD means that velocity of C with respect to the point D. Velocity of C with respect to the point D. Okay, so here you can see that D is the fixed point and C is the moving point. Okay, so it is capable of moving like this, right? And the velocity can be either in this direction, which is perpendicular to this link. Okay, either in this sense or in this sense. So now you can plot the velocity vector passing through the point D. Okay, so now you can mark the intersecting point as C. Now you can mark the velocity vector VCD, and this, the direction is like this. And the velocity vector VCB, the direction is like this. Velocity towards the point C, Here also VCD means that the velocity of C with respect to D, that means that towards the point C. Here velocity of VBA means that velocity of B with respect to A, and the vector will be pointing towards the point B. Here the velocity is VCB, which means that velocity of C with respect to B, and the vector will be pointing towards the point C. So next you have to identify the points E and F. You can see that the E is the point which is on link BC and which is exactly at the middle of the link BC, that is exactly at 200 mm from B as well as C. And the point F is located at 100 mm from the point D. You can see that from the question, a point on the link CD which is 100 mm from the points connecting the link CD and AD. The common point is D, and from that D point the F is located at 100 mm. Okay, so next we have to locate the velocity point of E and F. Okay, so A is here, B is here, C is here, and D is here. BC, E is located in BC. Okay, so E is located, will be in between this point somewhat over here. So I will tell you how to find this point E. So you can see that the link BC, okay, the link BC is of 400 mm, right? Link BC is of 400 mm and link BE is equal to 200 mm, right? So from the velocity diagram we can measure the dimensions of these vectors. Okay, so I am just taking dimensions. So upon measuring this particular dimension, it is found that it is in between 46 mm and 47 mm, and it is nearing 47 mm. So I am assuming it, I am taking this dimension as 46.8 mm. Okay, and upon measuring this dimension, it will be equal to 66 mm. And this is actually 66 mm. This is 46.8 mm. Okay, now we are going to locate the points E and F. So you have got a value corresponding to the configuration diagram and a value corresponding to the velocity diagram. So corresponding to the 400 dimension, you have got 46.8. So corresponding to the 200 dimension, what we have to do? Just take the ratio. And the value of VEB is equal to 23.4 mm as per the dimensions which we have measured. Okay. So by taking this dimension, you can mark the point E over here. Okay. Similarly, you can mark the point F. So for that, what you have to do? The dimension of CD is equal to 450 mm, and what we are required is DF, right? And which is equal to 100 mm. Okay. So this value is corresponding to the configuration diagram, and which will be equal to the corresponding values of CD and DF in the velocity diagram is equal to 66, VDF will be equal to 14.7 mm. So we can mark this point F 14.7 mm apart from the point D. Okay. So this dimension will be equal to 14.7 mm. So next we are going to complete the velocity table. So this is actually VB, VCB, velocity of C with respect to B. This is actually velocity of C with respect to D, and this is a grounded point. Both of these points are of grounded, so the velocity will be 0. So next we have to find the velocity of VE, and this is VF. Okay, and the value of VE will be also equal to VEA, also equal to VED. Why it is that? Any point, the velocity of any point with respect to ground, the velocity of a particular point with respect to ground, okay, is treated as the absolute velocity, and usually it is represented in the format VE, VF, VB, Vx, Vy. Okay, it is the absolute velocity. Okay, relative velocity, there will be 2 points. Okay, VEA, VEB, VCB, like that. Okay, here the question is the velocity of the point E. Okay, that is actually the absolute velocity, that is VE. So here VE will be equal to VEA, where A is the grounded point. Okay, grounded point, and also D also are the grounded point. Okay, so it can also be written as VEA, or which is also equal to VED. Okay, so you have to measure the value of VEA from this velocity diagram. So from this velocity diagram, you have to plot first the velocity of E. Okay, so this is actually VE, VEA or VED. Okay, upon measuring this particular velocity vector from this velocity diagram, it seems to be 65.5 mm. Okay, so the value of the value measured from the velocity diagram is 65.5 mm. So next we are going to find the velocity of point F. Okay, so VF will be equal to VFA is equal to VFD. Okay, it means that the velocity of F, the velocity of the point F, absolute velocity of the point F will be equal to the relative velocity of f with respect to the grounded point A, which is equal to the velocity of f with respect to the grounded point D. So upon measuring this dimension, it will be same as 14.7. Okay, so we can write this 14.7 mm. Okay, so now we are interested in this value and this value. How we can find this value? Okay, just take the ratio of these two available values. 7.2, that is actually the velocity VBA. So corresponding to the velocity diagram, the value is 72 mm. Here we require VE, here it is 65.5. okay, so upon solving, the value will be equal to VE will be equal to 6.5 meter per second. Okay, so the value will be 6.5 meter per second. Okay, so next is VF. So we are going to find the value of VF. That is, again we are taking the ratio of 7.2 is equal to 72 divided by VF is equal to divided by 14.7. okay, so from this we will be getting VF equal to 1.47 meter per second. Okay, so 1.47 meter per second. Okay, 1.47 meter per second. So our answers are VE is equal to 6.5 meter per second and VF is equal to 1.47 meter per second. Okay, so this is actually the velocity diagram will be looking like. This is the first vector that we are drawing, which is perpendicular to the I'm just marking the procedure once again. So this is the velocity vector VBA. This is the first vector we are drawing, which is perpendicular to the link AB. Okay, so the link is the vector is perpendicular to this particular link, this vector. Okay, next we are about to draw this vector BC. Okay, and this will be perpendicular to this link BC. So this vector we are going to draw next. Okay, so after that we are about to draw the vector AC. Okay, so this vector AC will be perpendicular to this link CD, and this is the third vector that we are going to draw. Okay, after that we can find the point E. We can find the point E and also the point F. Here the point F is there. Okay, somewhat the point F will be somewhat over here, and next you have to locate this point F and E by taking ratios. Okay, by taking ratios. After locating the points F and E, you have to join the points F and E to the zero velocity point. Okay, in order to find the absolute velocity. Okay, so next you have to join the point E to the zero velocity point. So this is your fourth vector that you are going to draw, and next is velocity vector FA. So here the velocity vector FD, VFD and VCD will lie on the same line. Okay. So after that you have to measure this particular length. I hope you have understood well about this velocity diagram, how to draw this velocity diagram. This table will be a very helpful one for you. So please try to solve this question. Thank you.